Hello dear friends, welcome back to this video in our YouTube channel. In this video friends, we shall be looking at the question you can see I have here on screen. It is a question based on projectile motions. Great, one of those important topics as far as the physics is concerned, mathematics with mechanics is concerned, and other areas in science. So friends, please watch the video from start to finish so that you can have a clear understanding on how the concept look like. Please friends, share the video out with your friends so they can have access to contents like this that can help them so well. Thank you very much guys, and it took me a lot of time guys to create this content for you, so I all of you guys to please give the video a thumbs up. That will go a long way to motivate me to keep producing more contents for you. Thank you very much guys, and let's dive straight into our video today. Thank you very much friends. As you can see, the question reads that a particle is projected from the point O with initial speed of 30 meters per second and passes through a point which is at a horizontal distance of 60 meters from O and a distance of 20 meters vertically above the level O. A. Show that there are two possible angles of projection. B. If these angles are alpha and beta, show that tangent of alpha plus beta is equal to -3. Alright guys, let's look at this first part, then we shall look at the other later. Great. So friends, it will be so good if we can have a clear picture on how the trajectory of the particle looks like. So friends, let's have the horizontal plane from where the particle is being projected, and the trajectory of the particle is going to start from O as the equation suggests. So guys, this is how the trajectory of the particle is going to look like, because this is a projectile motion and the trajectory is always a parabola, as you can have here guys, where there's a clear symmetry from the maximum height downward. Guys, it's a clear symmetry. Great. So friends, we are going to have the speed of projection, which the equation has suggested, which is 30 meters per second. Great. Then friends, we are now going to have the angle here, theta. Then friends, the vertical component, we are going to have it as Vy. Then the horizontal component, we are going to have it as Vx. Good. So this is what we have guys. Then now I think everything is done friends. Let's just bring forth the data in which we need to solve this problem. But friends, as we have Vx, we have Vy. Let's have their various values here. If we resolve the horizontal component guys, we are going to have our Vx will be the same like 30 cosine of theta, because Vx is the adjacent to the right angle triangle that is going to be made with the Vx vector and the speed of projection. Great. Then likewise guys, Vy, if we resolve, we're going to have 30 sine theta. And friends, the question has said that it was projected at a point with horizontal distance of 60 meters. So our x value there guys, our y value sorry, has to be 20 meters, because it said it was projected vertically above O, which is 20 meters. Then our x value guys has to be 60 meters. Good. So friends, now I think we have everything it takes to solve the problem. And the friends, keep in mind that if asked us to use the value of g to be 10 meters per second. Great. So friends, at this point now, as we have all the data we need to solve the problem, we can now tell them that from our equation of path that we all know, the equation simply reads that y is the same like x tangent of theta minus gx squared sec squared of theta all over 2u squared. Great. Where in this case guys, our u is simply the speed of projection, which is 30 meters per second. Good. So friends, if we plug everything now, we have our y to be what guys, to be 20, right? 20 meters. We are going to have 20 equal to x is 60 tangent of theta minus our g is 10. Then guys, x is 60, square that gives us 360, sec squared theta over our u is 30, squaring that gives us 900. Great. So friends, we have two zeros down, we have two zeros up, we can cancel them, that goes a long way. And we can also cancel two zeros all sides. We can also cancel the zeros we have all sides, in all the sides, because we have 20, 0 cancels here, 0 cancels here, 0 cancels where we have 10. Then the 2, then this 9 right can divide 36 to give us 4, right? Then this 2 can reduce the 4 to be 2. There's still a 2 here. 2 cancels all through. So simplifying guys, we are going to have 1 to be same like 3 tangent of theta minus sec squared theta. Great. But friends, what is sec squared theta according to trigonometry? It is 1 plus tan squared theta. So this guy turned out to be 1 equal to 3 tangent of theta minus sec squared theta, guys, is simply 1 plus tan squared theta. So friends, rearranging the equation, everything, we are going to have the quadratic equation tan squared theta minus 3 tan theta plus 2 equal to 0. Keep in mind, friends, that the question simply wanted us to show that there are two possible values of projection. So friends, this is where so many students get stuck, and they tend to take the wrong approach to answer this question. So friends, there are a number of ways in which you can actually do it. You can actually solve for those values and have it, but that will not sound matured. The best way to do it is simply to tell him that the roots of these equations are real. Okay, the roots of the equations are always, in fact, not just real, guys, they are real and distinct. Great. So we must try to verify to tell him the nature of the roots of this our equation. We are going to be using b squared minus 4ac. Okay, because we have to tell them, because we could still have equations like this and it is quadratic, but we don't have roots for them. So we have to tell them that this our equation has two distinct real roots. Great. So our b in this case, guys, is -3. Plug in everything, we're going to have -3 squared minus 4a is 1, our c is 2. So this is just going to give us an answer of 1. Good. We must tell them that 1 is what, guys, is greater than 0. Great. So our roots in this case, guys, are real and distinct. So we can conclude that there are two possible angles of projection. Great. That's it, guys. That's how we can answer the first part, to show them. Then now, guys, the next part saying that if these angles are alpha and beta, we should show that this condition is true. So friends, let's start by solving for those angles to get the angles. So let's factor out so well, guys. This is still the equation that we have. We factor out the equation, we look for two numbers, we multiply, it gives us 2, add gives us -3. Those two numbers, guys, since the coefficient of b is negative, those and the constant term is positive, those two numbers must be negatives. And those two numbers, guys, are 2 and -1. So, and since the coefficient of our a here, since the coefficient of x squared is 1, that is tan squared theta in this case is 1, we are going to have it as tangent of theta minus 1 into tan theta minus 2. And solving for theta, we are going to have tan theta to be equal to 1 or tan theta equal to 2. Good. So friends, we have the two angles now. We can therefore tell them that one of the angle now is alpha and the other one is beta. So we will tell them that we are going to have now tan alpha is equal to 1 and tan beta is equal to 2. Good. So now all what is left now is to show them that this condition is true. Great. So friends, we are going to recall that the tangent of alpha plus beta is the same like tangent of alpha plus tan beta, all that over 1 minus tan alpha tan beta. That is according to trigonometry, guys. So if we plug in everything, guys, we have tan alpha to be the same like 1, tan beta is 2. We are going to have 1 plus 2, all over 1 minus alpha is 1. That tan alpha is 1, tan beta is 2. So we have it like this. And guys, the denominator gives us 1 minus 2, which is -1. Up gives us 3. So we have -3 as our answer. Great. So we can never tell them that hence tangent of alpha plus beta, guys, is equal to -3. That is great, guys, as required. That's what the question required us to do. Great. So friends, don't forget to like the video, friends. Please like the video. It does motivate me to keep producing more great contents for you. Let's go to the next section of the question now. Let's move on to it, guys. Great, guys. Great. This is what we have. The next part reads that a particle of mass m kilogram moves in the inner surface of a smooth spherical bowl of radius 2a, describing a horizontal circle at the distance a below the center of the bowl. Prove that the speed is a square root of 3 ag, and we should find the period of revolution. Great. So friends, as always, let's try to picture out what the scenario looks like. Let's have it. That's the particle we have. Let's assume that it's a spherical particle. Obviously it has a weight. We also are going to call that mg, since they said the mass of the particle was m, therefore it has a weight of mg. Great. So friends, the particle is going to move in a spherical bowl, and the reaction force, the reaction of the particle on the bowl, this is the vector that is going to represent it. Okay, this is the line that is going to represent it. It's not going to be that horizontal, that vertical line that we all know, guys. Keep in mind that the particle in this case moves in a spherical bowl, okay, not that it hangs freely on a string. Okay, it moves in a spherical bowl, so certain things are going to change. I'm going to highlight all of those things that are going to change, because this is where most students always get confused when they're talking about a particle that moves in a spherical bowl. Great. So that's zeta. They are going to have the vertical distance from the center of the bowl to where to the same level at which the particle is in the bowl. Then friends, we are going to have the line that is joining that center to where the particle is, and at that same line where it describes the horizontal circle. Great. So friends, at this point now, we are going to insert the component that is going to prevent that particle from leaving its circular path. We have the component here. So friends, we also have the vertical component that is going to counteract the width of the particle, that is going to oppose the width of the particle. Okay. Then friends, let's keep in mind that this is going to be the angle, the angle made with the line, with the normal line. Okay, with the normal line, that is the reaction, okay, that is the line of the reaction force to the center where the particle is. Okay, good. So this is also going to be that same angle, because we consider these two lines are vertical, right? This blue line and this red line, they are vertical, so the angle subtended by them has to be the same. Great. So friends, this component has a component r equals theta. Then the component that is opposing the centripetal force, we are going to call that r sine lambda. Good. This is r equals lambda, sorry, this is r sine lambda. Good. So friends, we are going to insert the centripetal force, that is F subscript c, because it is a force that prevents the particle from leaving the circle. Okay, the force that is always center seeking. This is it, guys. Then friends, the radius of this of the horizontal circle made, we can call that small r. Then the equation has to give us some information. Then friends, this is going to be the reaction force. Like I said, this is going to be the reaction force. Keep in mind, the reaction force is not going to be as vertical as I said initially, guys. It is as I said, guys, this is going to be the resultant component, guys, is not going to be as vertical. It is rather going to have this slant nature, because in this case, guys, it moves in a spherical bowl. Okay, it moves in a bowl, so these are things that are going to change. Great. Then friends, the equation towards that the radius was what? 2a. Great. Then the vertical distance below the point where below the vector representing the reaction force has to be a, sorry, that is it. Then friends, we can recall that to get this r from Pythagoras theorem, which it is given as the square root of the hypotenuse, which is 2a, that is 2a squared minus a squared. 2a other squared, guys, simply gives us 4a squared. Then 4a squared minus a squared gives us 3a squared. In the square root, guys, simply gives us our answer to be the square root of 3a. Good. So that's the value of r that we have, guys. We can conveniently use it at this point. So friends, let's keep in mind that if we decide to look at this triangle, but not looking at the force part of it as a force part of it, okay, the part that contains the force component, but the part that has to do with the distance component, guys, we are going to see that our sine lambda in this case is going to be what? Opposite of our hypotenuse. Our opposite in this case is r. But what's r, guys, is the square root of 3a, right? All of the hypotenuse, which is simply 2a. So we are going to have the a and the a to cancel. We are going to have sine theta to be square root of 3. Good. Then friends, if you look at similarly, if you look at cos lambda, which is the same as 1/2, because cosine is adjacent over hypotenuse. Adjacent in this case is a, hypotenuse is 2a, so the a and the a they can cancel. We have 1/2. Great. So friends, now we can therefore go forward now to discuss with Newton's second law of motion. That from Newton's second law of motion, guys, oops, this was supposed to be w here. I'm sorry, guys, just really correct, please. Newton's law of motion, the second law, guys, it tells us that the sum of all the forces has to amount to the mass times the acceleration of the particle, that is x2 dot at the top. Great. That is the symbol for acceleration. Then, guys, if we resolve this our components vertically, that is the first component. Okay, resolving it vertically, guys, we are going to see that this arrow sign, this arrow cos lambda, guys, can balance with the weight of the particle. Therefore means we are going to have our arrow cos lambda to be equal to mg. Great. We can call this equation 1. Then friends, if you resolve horizontally now, we will see that this our centripetal force, guys, is going to do what? Balance with the component of it's going to balance with the component that seeks to prevent the particle from leaving its circular path. Great. So we are going to have that as and the centripetal acceleration, guys, we know that to be what? V squared over r, right? But let's just have it as that we are going to have our arrow sine lambda to be same like the mass times the acceleration. But we should know that the acceleration in this case is the centripetal acceleration, which has a value of v squared over r. Great. So this formula now turns out to be what? To be arrow sine lambda equal to our m stays the same, then x 2 dots is what? V squared over r. That's greater. Then friends, we can call this equation 2. That's right. Then friends, we should know that if our cos lambda in this case is 1/2, right? If we substitute cos lambda into equation 1, guys, we are definitely going to have our r to be something like what? 2mg. Good. 2mg. Then friends, if we substitute our r equal to 2mg in equation 1, we are definitely just going to have our r, which is 2mg. Then sine lambda, we know it's what? Root 3 over 2, which is this like mv squared over our r. In this case, we got it to be root 3a. So friends, simplifying it gives us our v squared to be the same like what? To be 3ag. Taking the square root, guys, simply gives us v to be the same like the square root of 3ag. Great. As required by the question. Then friends, the d part is saying that we should find the period of revolution. But friends, let's not forget that from v equal to 2 pi r over t, where this our v is the speed we have, then r is the radius, then this our t is the period, is what we are to solve. So friends, if we make period a subject, we are going to have our t to be same like 2 pi r over v. We have our v already, so everything is sorted. Our r is what we know already, so we are going to have our t to be 2 pi, stays the same. R is what we found here to be square root of 3a. All over v is what we have here. So friends, we simplify so well, guys. We are going to have our t to be something like 2 pi all times the square root of a over g. Great. So friends, that's what we have. Thank you so much, friends, for watching the video. Thank you so much for your patience, for your kindness, for your attention, for the time you spent to watch the video, guys, and I hope you found it interesting. If there's something you didn't understand, guys, please put in the comment section down below and I'm going to get to you as soon as possible. Thank you so much, and have a blessed day.